Dear children, here we are going to study graphical representation of data. Graphical representation of data. These data we can represent it on a graph. A picture is worth 1,000 words. A picture is worth 1,000 words. You all have heard these famous words. This is also true in case of statistics and statistical data. Sometimes it is not easy to make sense of just numbers and figures. If just we are collecting data means it is sometimes not easy to understand. So graphs and pictures help us to understand and analyze data and variations in data more easily. They also help us to identify patterns and make predictions more accurately. Graphs are of different types. Different types of graphs are there. The types of graph drawn depends on the type of data that it represents and the purpose of the graph. In this section, we will discuss some techniques of graphical representation of data. First one is pictograph. A pictograph represents ungrouped data with the help of pictures. Each picture in the pictograph represents a given quantity. Let us represent the distribution of number of workers of 5 workshops given below with the help of a pictograph. A, B, C, D, E. It is given there. Number of workers A, workshop A, number of workers 225, B 300, C 150, D 275, E 200. Let us represent 50 workers by a picture, face picture. The given distribution can be represented as A. 50 workers we have represented this picture. 50 plus 50, 100, 150, 200, 225. So A 225. B it is 300, 50, 100, 150, 200, 250, 300. So this one is a pictograph. That is not that much important. Then many cases we will not use this pictograph. That is first graphical representation. Now second one is a bar graph. That is an important thing. A bar graph is used to represent ungrouped data. Bar graph is used to represent ungrouped data. In a bar graph, the various items or heads are taken on x-axis while the frequencies are taken on y-axis. Heads are taken on x-axis while the frequencies are taken on y-axis. The graph consists of rectangles whose width is same and height is proportional to the frequency of each item. Height will be according to the frequency of each item. The bars are usually separated with a fixed gap between adjacent bars. So there is a gap between the adjacent bars. Now let's see an example. The number of hours devoted to various activities in a day by a student of class 8 are given below. For sleeping 8 hours, number of hours 8 hours, school 6 hours, study 4 hours, play 2 hours, and miscellaneous other things 4 items. The bar graph represents the above information is given here. Bar graph, you see the bar graph. We have to draw x-axis and y-axis, and this activity we will mark it on the x-axis. Number of hours frequency we have to mark it on y-axis. Then first 1 centimeter we will leave it. After that we will draw bar for sleep. Sleep 8 hours. Here it is marked 1 centimeter 2 unit 2 4 6 8. Then sleep 8 hours. Sleep up to 8 hours we have to draw a rectangle there. After that we have to leave 1 centimeter. Again next one. Sleep 6 hours up to 6. Here we have to draw a bar. Again 1 centimeter we will leave a space. After that study 4 hours. Study 4 hours up to here. Again 1 centimeter we will leave. After that play 2 hours. This one. Then miscellaneous 4 hours. That is a bar graph. Now next one, third one is a histogram. A histogram is similar to a bar graph. It is similar to bar graph. It is used to represent a grouped frequency distribution graphically. Then this bar graph also ungrouped, pictograph ungrouped frequency distribution table. And bar graph also ungrouped frequency distribution table. Here it is heads given school, sleep, school, study, play, miscellaneous, and frequency it is there. So that is an ungrouped data. Here histogram we use to draw for a grouped frequency distribution table. Then it consists of rectangular bars of equal width and height proportional to the frequency of each class interval. Frequency of each class interval. The class intervals are taken on the x-axis. Class intervals we will take it on the x-axis, while the frequency is taken on y-axis. There are no gap between the various bars in a histogram. That is the difference between a bar graph and a histogram. Bar graph, there is a gap between two adjacent bars, but here there is no gap between the various bars in a histogram. Let's see an example. Here you see. Let us draw a histogram for the frequency distribution given below. It is a continuous frequency distribution table, or we can say grouped frequency distribution table. 50 to 60 frequency 4, 60 to 77, 70 to 80 9, 80 to 96, 90 to 100 3. So how can we draw the histogram? First we have to draw x-axis and y-axis. Here it is there. X-axis, y-axis. And the x-axis, here you have to mark 0. Here we will mark x o, x dash, y o, y dash. And this one is 0, and we will mark start from 50 only, because in our question it is starting from 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100 given class interval. So, and frequency we will mark it on the y-axis. 1, 2, 3, 4, 5, etc. we can mark, because up to 9 only here in this question. So here it is here 0, and next 1 centimeter we have marked 50. Here it is 50 to 60. Here 10 unit only, but here it came 50 unit. 0 to 50 means 50 units are there. That is why we have to give a cut mark here on the first centimeter, cut mark. And this cut mark is called a kink, K-I-N-K, kink. So it is not continuous. If you are marking here 0, 10, 20, 30, 40, 50, etc., then no need of marking that kink. Here it is 0 to 50, 50 units are there. And 50 to 60, 10, 60 to 70, 10, 70 to 80, 10, 80 to 90, 10, 90 to 100, 10. But here it is 50. That is why, to show that we are giving that cut mark. Okay, now first class interval 50 to 60, frequency is 4, frequency 4. And there is no gap between the bars. Next one 60 to 77, 60 to 77. Next one 70 to 80, 9, frequency is 9. Next one 80 to 90, frequency is 6, frequency is 6. 90 to 100, 3, 90 to 100, 3. So that is the histogram. And here it is given 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. This class size is the same in all the class intervals. In case the class intervals are not same, some cases it may come, class intervals are not of the same size, we need to calculate the adjacent frequency for each class interval. We have to calculate the adjacent frequency. This is done by taking one of the class size as base size, usually the smallest one. Sometimes in this class interval, first one class size 50 to 55, 55 to 60, 60 to 70. That means the first one it came class size 5, but second one also 5, but third one is 10. And 70 to 80, 80 to 100. That means class size it came 5, 10 and 20. If the class size is different, then we have to find out this adjacent frequency. How can we find out adjacent frequency? First we have to choose one class size as base size. Usually the smallest one, smallest class size we will choose it as base size, and adjusting the frequency of a class interval by using the formula adjusted frequency is equal to base class size divided by class size of interval into frequency. Class size of interval into frequency. After that only we can draw the histogram. So here is an example. Draw a histogram for the following frequency distribution: 10 to 25, 20 to 40. 10 to 20, 10 only. 20 to 40 means it will come 20. Class size is 20. 40 to 50, 10. And 50 to 80, see, 30. Class size is 30. 80 minus 50, 30. 80 to 90, 10. 90 to 100, 10. So class size is different here. So in this case, we have to draw a column first. That is, in the first column we will write class interval frequency. It will be there in the question. Third column we will write class size 20 minus 10. 10. Class size is equal to what is the formula? Upper limit minus lower limit. 20 minus 10, 10. 40 minus 20, 20. 50 minus 40, 10. 80 minus 50, 30. 90 minus 80, 10. 100 minus 90, 10. Next column we have to find out adjusted frequency. Adjusted frequency. Here we have to choose a base size. Which one we can choose it as base size? 10. That is the smallest class size. So that we will choose it as a base size. So base class size divided by class size of the class interval. Base class size divided by class size of the class interval into frequency. 10 by 10 into 5 is equal to 5. 10 by 20 into 8 is equal to 4. 10 by 10 into 6 frequency is equal to 6. 10 by 30 into 15 is equal to 5. 10 by 10 into 3 is equal to 3. 10 by 10 into 1 is equal to 1. Then after that we have to draw the histogram. It is the histogram here, that is x-axis and y-axis we will draw. After that here 0 to 10, 10 to 20, 20 to 30 class interval will mark, and here it is frequency. Here you see first one 10 to 25 and adjusted frequency 5. So 10 to 20 we have to mark 5. 10 to 25. 10 to 25. Next one 20 to 40. 20 to 40 actually frequency is 8, but adjusted frequency we got 4. So we have to mark 4 only. Adjusted frequency only we will mark. 20 to 40. Here you see 20 to, not 20 to 30, 20 to 40 it is 4. Next one 40 to 50 we got the adjusted frequency 6. Next one 50 to 60 we got the adjusted frequency, sorry, 50 to 80. 50 to 80 we got the adjusted frequency 5. 5. Next one 80 to 90. 80 to 90 adjusted frequency 3. 90 to 100 adjusted frequency 1. So this way we have to draw the histogram if the class size is not same. Then next one, fourth one is a pie chart. A pie chart or a circle graph is used to represent ungrouped data. A pie chart or a circle graph is used to represent ungrouped data. It is of the form of a circle divided into sectors where each sector represents one value. The angle of each sector is proportional to the value of the item or percentage of the item. Thus, circle can be divided into sectors on the basis of the angles. Example given here. A fruit seller has a total of 60 kg of various fruits in his shop as given in the table below. Fruit mango 15 kg, apple 20 kg, orange 10 kg, papaya 15 kg. To prepare a pie chart for the above data, we first need to calculate the angle of the sector representing each quantity. This can be done by using the formula. What is the formula? Sector angle is equal to value of quantity divided by sum of quantities into 360. Sector angle we have to find out. So here we have to draw three columns. The first column fruit, the second column quantity. It is there in the question. The same we will write mango 15 kg, apple 20 kg, etc. Then after that third column we have to write a sector angle. Sector angle, how can we find out that? Value of quantity is 15 divided by sum of quantities. This total sum we have to find out. It is 60 into 360 degree. Then after multiplying this one we will get 90 degree. 20 is the quantity divided by total 60 into 360 120. 10 divided by 60 into 360 60 will get. 15 divided by 60 into 360 90. Here after finding out the angle you have to add it. Always we will get 360 degree. Now Draw a circle with a suitable radius and center O. Draw any radius OA of the circle. First, we will draw a circle of radius O. This one. Any radius you can take. A little bigger you have to make. Then after that, first we will draw this OA. A radius we will draw. Center you have to mark it as O. After that, OA we will draw it. From here, first angle we got here 90 degree. Mango 90 degree. So here we will draw using protractor. You have to mark 90 degree here, and right here 90 mango. Again from here we will measure. Next one, apple we got 120 degree. So from this line measure 120 degree and mark it there, apple 120 degree. And from this line we will measure 60 degree, orange 60 degree. Then from this line measure 90 degree, that is papaya. That is a pie chart. Okay, that we will not do here, later we will do. Next one, you see one more is there, that is a line graph. A line graph is used to represent data that changes continuously over a period of time. Line graph is used to represent data that changes continuously over a period of time. This type of graph is usually used to represent sales data, production figures, consumption of products, or to display any quantities that changes with the time, like height and weight. So now let's see an example. Here is an example. The sales figures of a company manufacturing TV sets for 5 years are given in the table below. Year 2015, number of TV sets produced 4,000. Company manufacturing TV sets for 5 years. 2015, company produced 4,000 TV sets. 2016, 5,500 sets. 2017, 3,500 sets. 2018, 4,000 sets. 2019, 6,000 TV sets. We will draw a line graph for the above data. See that, how can we draw it? Draw two axes, x axis and y axis. The years are taken on the x axis. Years we will mark it on the x axis. First 1 centimeter 2015, second 16, 2017, 2018 and 2019. Here it is 4,000, 5,500, 3,000, like that it is given frequency. So that is why we are going to mark it on y axis. Number of TV sets produced 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. Now first one, 2015, 4,000. 2015, 4,000. Here is 4,000. Just cross and round it, and you have to write there. You have to write there 2015 4,000 as an ordered pair. Next one is 2016 5,500. 2016 5,500. Here it is given 2015 4,000. 2016 5,500. 2017 3,500. 2018 4,000. 2019 6,000. Then after that mark all the points. A 2015 4,000, B 2016 5,500, C 2017 3,500, D 2018 4,000 and E 2019 6,000. Then join all these points with a straight line. Then we will get the line graph. So these things we are going to study in the next exercise 16.3. So we will start the exercise in the next video. Thank you so much.